In this video, we're going to look at using Desmos to plot some bivariate data into a scatterplot, find the line of best fit, find the Pearson's correlation coefficient, our R value, and the coefficient of determination, the R squared value. So for our example in this, we're going to use a question out of the textbook, question 3, where we've got the temperature of each day and the number of drinks that were sold. The question asks us to calculate the R value for the data above, but we're also going to plot it and also find the R squared value. So to do that, first of all, I need to put in my data. So if I click up here, I can include a table and put in my X and Y axis data. So I'm entering the temperature data into my X values because that is my independent variable, which will go on my X axis, and I'll plot the number of drinks sold to go on my Y set of data because my Y axis is my dependent variable. So I've entered my temperature, my X values, the number of drinks sold for my Y values, and you can see that it's plotted the points on my scatter plot. Now just be wary, please note that I have already adjusted the scale of my window to match the range of my values. So looking at this data, you can see that there is a positive trend and it does look like there is a linear relationship. So I'm going to have a look at what this linear relationship could be. So to put my linear regression or my line of best fit on here, I'm going to type in Y1, so my Y data that I have is approximately equal to B, which is my gradient, times X1 plus A, which is my Y-intercept. And you can see that it's graphed on here a line of best fit. And with my A value being my Y-intercept, and my B value being the gradient of the line. Now we can see here that it's also given me my R value, which is my Pearson's correlation coefficient. And what it does is the closer that is to 1, the closer my linear model represents my data. And because this is positive, there's going to be a positive relationship between my data. Now the other value that it's given here is my R squared value, which is my coefficient of determination. Same again, the closer that is to 1, the closer my model represents my data or fits my data. Now, the other thing we're going to have a look at is the residuals. You can see here it allows me to plot my residuals. My residuals is basically the difference between each piece of data and the model that's been created. So let's plot these residuals and see what that looks like. I'm just going to move my screen up because I'm missing my first one. Now there's two things to notice. One, the closer my residuals are to my horizontal axis, well then the closer they are going to be to that linear relationship. But the other thing that we need to look at is a residual plot on the graph. If the residual plots are random as they are here, it says the linear regression model that I've chosen is the most appropriate, or that there is a linear relationship between the data. If these form a pattern, like it's not a random arrangement around my x-axis, the horizontal axis, then I'd say that the relationship between my data is going to be a non-linear relationship, and another different type of model would probably be more appropriate.